Hello everyone, today I am going to explain the solutions of Codeforces round 790 division 4. I will explain all the problems. So let's start with problem A. In problem A it says that we are given a ticket which consists of 6 digits. Now we have to tell whether the ticket is lucky or not. Now a ticket to be lucky, the sum of the first 3 tickets has to be equal to the sum of last 3 tickets. Now there is nothing to explain in this problem, we just have to calculate the sum of the first 3 tickets and also the sum of the last 3 tickets and just have to check that whether they are equal or not. So the code is very simple, let me show the code. So here we are first taking input as a string. Now I am adding the value of the first 3 tickets in my answer variable. Now since these are characters, to get the integer value we have to do minus character 0 to get the integer value, and then I am again subtracting the values of the last 3 tickets from the answer variable. Now if the first 3 and last 3 tickets have same value, like the sum of the first 3 and last 3 have same value, then answer will be 0. So if answer is 0, then I will print yes, and otherwise I will print no. Now let's see the second problem. Now in second problem we are given n boxes with different quantities of candies in each of them. The ith box has ai candies inside. Now you have n friends that you want to give the candies, so you decided to give each friend a box of candies, but you don't want any friend to get upset, so you decided to eat some candies from each box so that all boxes have the same quantity of candies in them. Note that you may eat a different number of candies from different boxes, but you cannot add candies to any of these boxes. What is the minimum total number of candies you have to eat to satisfy the requirements? Now let's say we are given 5 boxes with different number of candies, 5, 2, 7, 11 and 8. Now we can take out candies from each boxes, but we cannot add in any of them. So what we can make sure is that we can give everyone at least 2 candies, right? Like if we gave each of my friend 2 candies, then I have to take 3 candies from here. I don't have to take any candies from here, but I have to take 5 candies from here. I have to take 9 candies from here, and I have to take 6 candies from here. Then all the boxes will have 2 candies, and we can give them to all my n friends, like 5 friends. Now I can give them 1 candies also, like I can keep 1 candies in each box also, but again then I will have to take out more candies, but I have to find the minimum number of candies. So I will try to maintain the minimum number of candies currently available in the row of the boxes to all the boxes. So currently the minimum number of candies in a box is 2, so I will try to maintain the number of candies as 2 in all of my boxes, and for that I have to calculate how many candies I have to take out, and that's the answer for this problem. So let's see the code. So first I take input in my array. Now I sort the array because all the boxes will have the least amount of candies which currently has in one box. So the 0th index has the least amount of candies, and all other boxes will have the same amount of candies. So what I do, I go from index 1 to index n minus 1, and for each box I add to my answer variable that how many candies I have to take out from the ith box, so that the number of candies in ith box becomes equals to 0th box, and that's my answer, so I print it. Now let's see problem C. Now in problem C it says that you are given n words of equal length m consisting of lowercase Latin alphabet letters. The ith word is denoted SI. In one move you can choose any position in any single word and change the letter at that position to the previous or next letter in alphabetical order. For example, we can change E to D or F, but we can change A only to B. We cannot change A to Z. Also Z can only be changed to Y, but it cannot be changed to A. Now the difference between two words is the minimum number of moves required to make them equal. For example, the difference between best and cost is 1, like B and C has a difference of 1, and E and O has 10. S are equal, so they have 0 difference, and T and T also have 0 difference. So the answer is 1 for best and cost. Now we have to find the minimum differences of Si and Sj that is, we in all the combination, all the pairs of words we are given, we have to find the minimum difference over all possible pairs of n words. So let's see what it's basically saying is that, let's say we are given 3, like n is 3 and m is, let's also 3. M means the length of each word and n is number of words. Now let's say the 3 words are A, B, B, Z, B, A and B, E, F. Let's say these are my 3 words. Now I have to find that pair of word, like I have to find the pair of words, not the word, like I have to find the minimum number of operations required to make 2 words equal. Now see, for if I consider first these 2 words like A, B, B and Z, B, A. Now I can make A equals to Z, right? Now to make A equals to Z, I have to increase A by B, then C, then up to Z. Now this will cost how many operations? Like A is 0 and Z is 25. Like it will cost me 25 operations. Now these 2 B are equal, so it will cost me 0 operations. Now I cannot, like I can make B equal to A or A equal to B, but basically the number of operations will always remain the difference between B and A, which is absolute value of A minus B. So it will be 1. So total number of operations here, it will be 26. In the same way, I can check for Z, B, A and B, E, F. Now let's say 26 is my answer 1. Z, B, A and B, E, F is another pair, possible pair, and for 8, let's say the answer is answer 2. Alright, and let's say the another pair is A, B, B and B, E, F, and for this one the answer is answer 3. Now I have to print the minimum of all these possible answers. So the number of words is n is 550. So we can do a n square operation to check for all the pairs, which we will have to actually calculate, of course. And also the number of the length of each word is also in between 1 to 8. So we can do a brute force approach for this one. So let's see the code. Now first I create a vector of string of n size and I take the input. Initially my answer is infinity because I want to minimize the answer. Now I go to each pair, like for I 0 till n minus 1 and j I plus 1 to n minus 1. This way I check for all the pairs of words, and for each pair initially my answer is 0, like number of operations. And for these 2 words, like ith word and jth word in the vector string v, I check, like I have to, like first I convert the character to its integer value into A and B, and I know that the minimum number of operations required to make one character equal to another is the absolute difference between them. So I add that value in my current, and now after doing all the operations, I check if my current answer, like if my current is less than my answer. If that is true, then my current is the actual minimum answer, so I put it like A mean answer current is nothing but like it is a template written like over here somewhere, like A mean A comma B is equals to A equal to minimum of A comma B. This way I store the minimum value of answer and current in my answer, and I finally print the answer. So that was problem C. Now let's see problem D. So Timur's grandfather gifted him a chessboard to practice his chess skills. This chessboard is a grid A with n rows and m columns, with each cell having a non-negative integer written on it. Now Timur's challenge is to place a bishop on the board such that the sum of all cells attacked by the bishop is maximal. The bishop, one second, yeah, my sound is coming. The bishop attacks in all directions diagonally. There is no limit to the distance which the bishop can attack. Note that the cell on which the bishop is placed is also considered attacked. Help him find the maximum sum he can get. So I hope you guys know what a bishop is, but what basically bishop does is bishop can move diagonally in any direction and it has no limit. Now we are given a chessboard of n cross m, let's say this one. And there are some values like this one 1 2 2 1 2 4 2 4 2 2 3 1 2 4 2 4. Okay, there are some values here. Now we have to calculate the maximum value we can achieve. Like if we place the bishop here, we can go in this direction, also in this direction, also in this direction. Alright, now again if we start from here, we can go in this direction, and this direction. Now among all these possible positions from where the bishop can start, we have to calculate the maximum value we can obtain. Now here we can see that the value of n and m is 200, and also it says that the value of n cross m does not exceed 4 into 10 to the power 4. So actually we can do a brute force approach for this code also. Like there are 4 into 10 to the power 4 cells, and for each cell if we try to check the diagonal values, it is almost around 2 into minimum of n comma m. So let's say it is 200 because the maximum value of n and m is 200. So 200 into 4 into 10 to the power 4 lies within the time range, because we can do around 2 into 10 to the power 8 operations. So brute force also work for this code also. Now for checking the diagonal, this is very easy. Like if this is a grid, so the indices are 0 1 2 3 4 5 0 1 2 3. So I am writing the indices of each cell 0 0 0 1 0 2 0 3 0 4 0 5 1 0 1 1 1 2 1 3 1 4 1 5 2 0 2 1 2 2 2 3 2 4 and 2 5 3 0 3 1 3 2 3 3 3 4 and 3 5. Now let's say we start from this cell. Now if we start from this cell, the diagonal values are this, like this is the diagonal direction in this direction, this and this. So when we are checking for the left diagonal, we can see that the values of rows and columns are decreasing. When we are checking the right diagonal, then the value of column is increasing, like 4 3 4 5, but the value of row is decreasing. Same way when we are checking the bottom left diagonal, the value of column is decreasing but row is increasing, and for the right bottom diagonal, the value of row and column both are increasing. So thus we can check all the values in the diagonals, and also we have to add the value in value of the cell in which we are currently at, and thus we can calculate the answer. So again I first take the input in a 2D array A. Now I have created a function to check, and for each cell I get my answer in current, and if my current is greater than my actual answer, then I put that value in my answer and I finally print my answer. So how I am checking it? So currently I am at RC, like in row R and C column. So my current, like I have to add the value of the cell currently where I am, so I am adding that in my current, and then I am checking for the left upper side diagonal. Just I showed the way, like the row and column both will keep decreasing, and I will add that value in my current until I is greater than 0 and j is greater than 0, which means we are within the grid. Then I check for the right up diagonal, left bottom diagonal, and then I check for the right bottom diagonal, and finally return the value. And I here, as I said, I check the value. If the current value is greater than answer, then I store that in my answer. and finally I print my answer. So that was problem D, very easy problem. Now let's see problem E. In problem C it says that Timur has n candies. The ith candy has a quantity of sugar equal to ai. So by eating the ith candy, Timur consumes a quantity of sugar equal to ai. Timur will ask you q queries regarding his candies. For the jth query, you have to answer what is the minimum number of candies he needs to eat in order to reach a quantity of sugar greater than or equal to xj, or print -1 if it's not possible to obtain such a quantity. In other words, you should print the maximum possible k such that after eating a minimum possible k such that after eating k candies, Timur consumes a quantity of sugar of at least xj, or say that no possible k exists. Okay. Now the value of n and q both can lie up to 10 to the power 1.5 into 10 to the power 5. Okay. Now first the observation is we have to minimize the number of candies for each time. So if we have to minimize the number of candies, then it's better to eat those candies first which have higher sugar level, right? So if these are the candies, so always we will try to eat the candy which has the highest sugar level, and if that does not fulfill our criteria of x sugar, then we will add the next candy with higher sugar level, and we will keep doing that until we reach the level x. And if after eating all those candies still we cannot reach the sugar level of x, then we will say that it is not possible to gain that sugar level. Now the number of elements, like the number of candies, can be up to 10 to the power 5. So for each query we cannot do a 10 to the power 5 operation, like we keep eating the candy with the higher sugar level, because that will give TLE, because number of queries 10 to the power 5 and the number of candies 10 to the power 5, so it will give us time limit exceeded error. So first what we will do, we will sort the array. So let's say the candies were like this one. Let's take a smaller example. Let's say the candies were 3, 2, 1, 4. So first we will sort the array with the in the decreasing order, like 4, 3, 2, 1, so that we eat the highest candy first. Now what I will do, I will maintain a prefix sum array which will tell that if I eat all the candies up to ith candy, what is the amount of sugar I will obtain. So if I just eat the first candy, see, I will always try to eat the maximum sugar level candy first. So first I will eat the candy which has the maximum sugar level, which is 4. Now if I eat the second highest sugar level candy, then my total sugar consumption will be 7, then 9, then 10. Now for each query, let's say I am given a value x and I have to check whether I can obtain this x sugar using those eating those candies or not, and if I can, then what is the minimum number of operations. So instead of checking in, like, this is simple binary search which will take log n time, so thus it will not give us any TLE, because 10 to the power 5 into log of 10 to the power 5 lies within the time limit range, like the number of operations will remain less than 10 to the power 8. So that's it. First we have to sort the array, then we have to maintain an array of prefix sum, and we have to binary search on that one. So let's see the code. So yeah, first I take the input in my array, then I sort it in the decreasing order, then this is my prefix sum array sum, and I calculate my sum here. Now for each query I take input x, the required sugar consumption level, and I try to get the index. Okay, so I'll use my lower bound function. LB means lower bound, I have defined it here. LB is lower bound. So I search for the value x, because if we consume sugar equal to x or greater than, it will be fine. So we can just exactly consume x level of sugar, and I try to just get the index, like in the prefix sum array, this is 0, this is 1, this is 2, this is 3. Let's say my x is 8, so lower bound will give me this index 2. Now I check if index is, like if index is 2, then that means I have eaten 3 candies, so I print id plus 1. Now let's say my required consumption level was 12, then my index will be 4 and the size of the array is also 4. So if my index is equal to n, that means it is not possible to consume that level of sugar, so in that case I print -1. So that's it. Now let's say problem F. Given an array A of length n and an integer k, you are tasked to find any two number L and R such that for each x which lies in the range L to R, x appears in A at least k times and the value of R minus L is also maximized. If no number satisfy the condition, then output -1. Now what this problem basically asks, let me explain that. Let's say our array is 11, 11, 12, 14, 13, 14, 13. Okay, this is my array, let's say. Now I have to choose the value of L and R such that all the values like L, L plus 1 till R, all the values exists in the array, and we are also given a value k. In this example, let's say value of k is 2. Now all these value L, L plus 1, R exist in the array, and the number of occurrence of that element in the array is greater than equal to k. Now let's see for 11. Now if my L and R both are 11, okay, in that case, see, 11 number of occurrence of 11 in the array is 2 and we need at least 2 occurrence. So this is a possible range, both are 11. Okay, both are 11 here. Now if I try to take 12, now number of occurrence of 12 in the array is just once, so it is less than k, so we cannot take 12 in our answer. Now if I try to take 13, okay, now if I try to take 13, 13 is in the array 2 times, so I can consider 13. So my another L and R can be 13 and 13. Now comes 14. Now 14 also occurs in the array and number of occurrence is also 2, so another of the option is taking L and R both equal to 14. Now we have to maximize the value of R minus L. Now if we can see that 13 also exists in the array at least k times, 14 also exists in the array at least k times. So if we take L equal to 13 and R equal to 14, the what are the numbers between this range L and R? These are 13 and 14, and both of these numbers exist in the array at least k times. So we can take the final range LR equal to 13, 14, because this is the range which gives the maximum value of R minus L. So this will be the answer. And in case there is no such option, like let's say the array is 1, 2, 3, 4 and k is 2, in this case no element exists at least twice, so in this case the answer will be -1. So that was for the so that's the thing of this problem, and I think this was more of an implementation based problem. So let's see the implementation, then it will be more clear. Okay, yeah, so first I take input, okay, and I tried use a map to store the occurrence of that exact value in the array. Also I insert all the elements in a set just to get the unique values in a sorted order. Now initially my left and right, which is my actual answer, is -1, and after inserting all the elements in the set, now the set contains only the unique elements in the increasing order. So I store all those values in my vector v. Also I put a 0 at the beginning of the array v. We'll see that later why this is required. Now m is size of v, and just the way I showed that if this is the array like 11, 12, 14, like this one, 11, 11, 12, 13, 14, 14, 13. First we'll sort the array 11, 12, 13, 14, and I have taken 0. This is my v, and in my map it stores number of occurrences. For 11 it is 2, for 12 it is 1, for 13 it is 2, for 14 it is 2. Okay, now we have to take consecutive elements in the range, because if I take L and R, then all the elements L, L plus 1 till R, all these elements have to be present in the array at least k times, right? So if none of the elements exist in the array at least k times, then the answer is not possible. So first I check that, like I go through my array of v, and I check if map of vi is greater than equal to k, that is the occurrence of that element is greater than or equal to k, then my left and right is that element, and I break from the array. Now I check after this, if still my current left and current right is -1, that means there was no element which has at least k occurrences, so I print -1. Otherwise, let's say in this case, when I came to 11 in the array, its occurrence was 2, so my current left and current right both are 11, and also my answer left and right both are 11 at this moment. Now after that I try to increase my range, right? Because if currently my range supports 11 to 15, and there is a element 16, I will check if 16 occurs at least k times. If it occurs, then I can increase the range from 11 to 16. Otherwise I can store 11 and 16 as my answer, and I start 11 to 15 as my answer, and I start a new range from 16, and when it will end, I will check if this range is greater than the previously stored range, and if it is greater, like 16 to 22, then this will be my answer, right? So how will I do that? Let's see in my code. So after here I try to check each element, like currently I am ith index. Now if my vi is equal to vi minus 1 plus 1, that is if currently my current element is 15, then the previous element must be 14 in order to increase the range. And also if my current right is equals to vi minus 1, that means currently I am at 14, and my last range, like for example let's see here, now currently I am here, okay, it is 12. Now I check if my vi minus, like the difference of these two elements is 1, yes it is 1, then I check if my current right is the previous element or not. Yeah, previous element was 11, and my current right is 11. Then I check if my occurrence of this current element is greater than equal to k or not. But we can see that currently the element 12 has only one occurrences, so we cannot consider this in my range. So since this does not satisfy, then in my else condition I will check if my map, I will come here because this says that the occurrence is greater than equal to k otherwise. So we can say that we have to start a new range, because 12 does not exist in any range at all. So my current left and current right is -1, -1, but left and right is still 1, because that is my current actual answer. Till now we have found that as our answer. Now I come to the next element, which is 13. Now I check that vi is equal, the difference of 13 and 12 is 1. Current right is not 12, right? My current right is -1, so I won't consider it. Now I come to this part, and I will check that the occurrence of my current element is greater than equal to k or not. So 13 has 2 occurrences, which is fine because k is equal to 2. So at this moment my new range will start from 13. So my current left and current right both will be 13. Okay, then I will come to this element. Again I will check that the difference between the previous and the current element is 1, which is fine. Also the current right, like current right of the range is 13. Here we can see that. Also the occurrence of my current element 14 is greater than equal to k, because it has 2 occurrences. So this tells us that we can expand our range from 13 to 14. I am doing that. Current right equal to Vi. So here I have updated my current right equal to 14. Now I check if my current right minus current left, which is 1, the difference between them is greater than equal to my actual right and left, which is 0. So here we can check that this is a better range, 13 to 14. So I'll update my left and right with current left and current right. So my current left will be 13 and current right will be 14. And after that it ends, like we come out of the array. So I will print my left and right. So this is how I will check that if the current element can be extended as the part of the previous range, then we will extend it here. Otherwise I will check whether I can start a new range from here or not. In order to start a new range from here, the current element has to have at least k occurrences, and if that is not possible, then that means we have to skip this element totally. So we have to if we can start a range later, that will have to start from that next future element. So my current left and current right will be -1. So that's it. Now let's see problem G. In problem G, it is said that you are given a rooted tree consisting of n vertices numbered from 1 to n. The root is vertex 1. There is also a string S denoting the color of each vertex. If Si equal to B, then the vertex I is black, and Si equal to W, the vertex I is white. A subtree of tree is called balanced if the number of white vertices equals the number of black vertices. Count the number of balanced subtrees. A tree is connected undirected graph without cycles. A rooted tree is a tree with a selected vertex, which is called the root. In this problem, all trees have root 1. Now it says the type of input, like how we are given the parent. So AI is the parent of the ith vertex, and we have to actually tell the number of balanced subtrees. Now let me explain the problem a little bit more. Like we will be given a tree like this. Okay. Now each vertex is either colored white or colored black. Let's say these are the vertices which are colored white. Okay. Now I have to calculate the number of balanced subtree. Now how a subtree is balanced? If in a subtree the number of blue and white nodes are equal. So we can do this recursively very easily as any other tree problem. Currently I am here, right? Currently my red number of blue nodes, number of black nodes is 0 and number of white node is 0. Currently I am at this node. Okay. Now my current node is white, so I will increase the number of white node by 1. Now I will ask recursion to give me the number of blue and white occurrences in this subtree. Let's say it gives me B and W, and I will ask my recursion to give me the number of subtrees in this part. So it will calculate recursively, and this will give me the number of values of B and W, and this B and W will be added. So in this subtree, the number of blue node, black node is 1, 2, 3. Again the number of white node is 1, 2, 3. Here the number of blue node is 2, the number of white node is 2. So total here for this subtree, the whole subtree, like the whole tree, number of blue nodes will be 0 plus 3 plus 2, and here it will be 1 plus 3 plus 2. So in total for the whole subtree, the number of blue nodes is 5, the number of white node is 6. so these are not equal, so the whole subtree is not a balanced subtree. But there are inner subtrees also, and for those the recursion we will calculate. Like for this one, when we will call recursion on this one, for this subtree number of blue subtree will be 2, a black subtree, and number of white subtree will be 2. So this is a balanced subtree. It will again ask recursively for this subtree, and this is again unbalanced because only one nodes are there. Every children node, the subtree rooted by the children node will always be unbalanced because there won't be equal number of blue and black and white nodes. So again this is a balanced subtree, this is not a balanced subtree at all, and 1 2 3 1 2 3, this is a balanced subtree too. So probably the balanced subtree here is 3. So let's see how we can do in code. This is again a very easy tree problem. So first I take my input n, I store the inputs in my array A, then I create a tree using the 2D vector g. Then again I take the string s as input, and I have pushed back hash here because the nodes in my question are numbered from 1 2 3 4. Alright, now in my string, let's say my string is bwbb, so the indices are 0 1 2 3. So what I have done, like this is actually pointing to the color of the first index, so I have pushed a hash here. This is 0 index, this is 1, this is 2 3 4. Alright, now I can directly fetch the color from the string s. This is not necessary at all. Now I have created a DFS function. I have called a DFS from my root, and for root my parent is 0. You can set it as the parent as also root. Now initially for my current node, the blue and white are 0, color of blue nodes and white nodes. Now if my current node is blue, the color of current node, the colors are stored in my s string, then I increase the number of blue node by 1, otherwise I increase the number by increase the number of white node. Then I recursively call DFS on each of its children, like how many blue and white nodes are there in its subtree, in the children's subtree, and I add that number with my blue and white. Now if blue and white are equal, that means my current node, the subtree rooted at my current node is balanced. So I increase my answer by 1 because the answer is the number of balanced subtree. And finally I print out my answer. So that was problem G. Now let's see problem H. The problem H has one easy version and one harder version. In the easier version, n is less than equal to 1000. First let's see the problem. So a terminal is a row of n equal segments numbered 1 to n in order. There are two terminals, one above the other. You are given an array A of length n for all I 1 to n. There should be a straight wire from some point on segment I of the top terminal to some point on second AI of the bottom terminal. For example, the following picture, here it is shown the picture. A crossing occurs when two wires share a point in common, that is they intersect each other. What is the maximum number of crossings there can be if you place the wires optimally? So let's see the problem. Like, let me explain that. Let's see, this is the array 4 1 4 6 7 7 5, and let's say their indices are 1. Let me take one best index 1 2 3 4 5 6 7. Okay, now there are 1 second please. Okay, so now let's say the rod is like this, the two rods 1 2 3 4 5 6 7, 1 2 3 4 5 6 7. Okay, now my first rod start like 1 2 3 4 5 6 7, 1 2 3 4 5 6 7. Now my first rod starts from here and it connects, like it goes till 4, goes to the fourth segment, so it will come somewhere here. Now my second rod starts from here and it goes in the segment 1, it goes in the segment 1. Now thus we have this way I have to calculate the number of intersections. So when the intersection will occur actually, now we are given the end point for each rod one by one. Now let's say already there are these many rods. Okay, let's say there are these many rods. Now my next rod starts from here. Now let's say its end point is here. Okay, now this rod will intersect only those rods, this rod will intersect only those rods which have started before this rod and they have ended after the end point of my current rod. Like these are the previous rods, and in this rod my current rod will intersect with only those rods which have ended after the end point of my current rod. So let's say my rod was like this. So in this case, let's say let me take one more better picture, like 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5. So my first rod goes 1 2 3, my second rod goes from 2 to 1, my third rod goes from 4 to 4. Now let's say my fourth rod starts from 4 and it goes to the second segment. Now how many rods will it intersect? This rod will intersect only those rods who have started, like only those previous rods. The fourth rod will intersect only those of these previous rods who have ended after the end of this rod. Like this rod has ended at 2, so only those rods between 1 to 3 who have ended after 2 or at 2 will intersect. So here only first rod and the third rod have ended after 2, so the number of intersection will be 2. So this is all we have to check. For each rod we have to go to the previous rods and we have to check that how many rods have ended after or equal to the end point of my current rod. So since in the easier version the number of rods is 10 to the power 3, so we can do a 2D array, we can use a 2D loop and we can do it in brute force method. Like for each rod we can go to all the previous rods and we can check. Like this is the code. Here for each rod starting from the second rod, I am going for each rod, I am checking the previous rods, and if any of the previous rod has ended after or at the same point of my current rod, then they will intersect and my answer will increase. So that is all you have to check. Now in the harder version the number of rods is 10 to the power 5, so you cannot use a 2D loop because the number of operations will be 10 to the power 10. So we have to do something better. Now here comes the use of ordered set. Now ordered set, if you know then you know, otherwise you have to learn about ordered set. Like if in ordered set I can find how many values are greater than me in the current array. Like let's say my current ordered set looks like 1 to 7. Now if I insert 5 here and then I try to check that what is the order of my 5, then it will give me 2, because this is index 0, this is index 2. This means that there are 2 more elements which are currently smaller than me. Alright. Now this ordered set can also be in reversed order, like 7, 5, 6, 3. So every time I have to check, right, that how many how many rods have ended after me. So if let's say there were 3 rods before me whose end points are 7, 5 and 3. They are in sorted order. Now my current rod is 6. Current rod's ending point is 6. So in my ordered set it will come here. Now the index will be 1. So that means there is only one rod which has ended after or equal to me. So this is the number of elements and number of intersection for my current rod. Also there is one more thing, like in the ordered set, let's say there were 2 7 6 5 3 and my current rod again ends at 6. Now if I try to find the order of my current value 6, it will give me 1 because this is index 0, this is index 1. So according to that it will tell me that there is only one value which is greater than 6, but actually this 6 was already there and this is my current 6. So the answer should be 2. So for that what we can do, we will get the order, like the order will give us how many values are actually greater than 7. This will be 1, and in map we will store the occurrences of 6. Before this element the occurrence of 6 was 1, so we will add 1 plus 1, thus the total number of rods which have greater than or equal to ending points of my current rod will be 2. Thus, and for this check query, like for finding the order of key and inserting, it takes log n time, so the number of operations will be n log n, so this will be accepted. Like here for the same thing I am keeping a map and a ordered set. You can find about ordered set on YouTube. Now for each element I first insert the current element in my ordered set. Now this is the function to get the index of my current element, and this is my ordered set in increasing order. Here you can see the code. This is greater equal, which means there can be same value more than once and they will be in decreasing order. Now I get the order of my current key, like how many elements are greater than my current key till now, and also there can be some elements which are equal to my current key, that is stored in my map, so I add that too, and after that I increase the value occurrence of my current value by 1 in my map, and at the end I will print the answer. So that was it. So now I have explained all the problems for this round, and thanks for watching.